Good afternoon, everyone. Am I audible? Good evening. Am I audible? So just let me know, am I audible or not? Am I audible? So we have some of the viewers. So once I'm audible, so I can proceed further. Okay, right. Thank you. All right. So we can start our session. Thank you. Thank you. Please keep interacting. So we will know that possibilities. I'll be keeping to so write something in the chat box. So if you have anything, so we can discuss about that. Okay. Okay. You can proceed. Okay. So first, the main agenda of all right. Okay. So first, I can get some responses. All right. So first we will our agenda is to clear the concepts and some of the tips that how you can proceed in upcoming few days and what are the important areas to focus with and some of the tips and tricks that are basically needed over here. And if you have on the session, if you have any relevant doubts, so we can also clarify accordingly. So first, let's start with the syllabus. We'll see what are the things are there and what are the important areas in this syllabus. Okay. So as we can see, we can classify this particular subjects, aircraft structures, concepts, and tips in four different ways. Okay, we can keep this into four different classifications. As you can see, the first and foremost, what we have is a strength of material. The first and foremost, we have the strength of material, and which is one of the like if the full if I take like 100% question, it comes from the structure. Then out of that, the 25% of question will be coming from the strength of material, right? 25 and remaining, you can say 5 to 10% will be asked from these areas. So you can understand the importance of strength of material. Now, in additionally, we will also discuss what are the core areas you have to focus, what are the important topics that you have to focus. Yes, I will come to that point as well, open section, closed section, and what are the tricky things that you have to keep in mind. Everything I will come into that and how you can prepare for those particular topic, right? And before proceeding this particular aircraft structure is one of the very it's one of the very scoring part, very scoring part. And here basically they will ask based on the formulas. If you have the formulas handy, if you remember the formulas, if you remember the formula, then you can solve it. And second important thing is once as I've said, I will write down the important points side by side, things you should remember. One is a formula. Okay. Formula you have to remember. Second, how the formulas are interconnected with one another. Okay. Interconnected. Okay. Now when I talk about the interconnected, let's I will give that example of those things, right? When I'm discussing, we'll give that. And the third one is your application. You have to be careful with the units, very precisely units. And for the NAT type of question, like whether they're asking for decimal place or they're asking for integers, round off to integers, so you have to be careful with that. And yes, that's all. You have to keep it handy. Formula means how those formulas are interconnected with one another, and what is the application, units, and decimal, all those things. And the fourth one, top of that, is a procedure. There are certain rules and regulations for solving certain things. So if you know the procedure, you it is going to be easy for you to solve. And definitely it's one of the very much scoring subject, and you can avoid some sort of negative marks also because of this. And remember, when it comes to the gate exam, the questions are obviously going to be complicated, right? So without wasting much time, let's focus on the particular topic. So as I've said, strength of material is one of the very, very, very important thing. Now, what are the possible questions and how you can plan your study or for your last moment preparations, or we can say the last moment? What are the important topics you can't miss at all? So first, I'm going to emphasize you can't miss the strength of material topic which we have mentioned. First and foremost topic, we have the stress strain, right? So you know the definition. So here in this gate examination, talking about gate examination, nobody is going to ask you the definition, but they will obviously, there is a chance of asking the relation. What is a relation between stress and strain? Like, now I will come to the point of interconnection, how I can interconnect stress and strain. Let's assume I have one cube, okay, of material of copper, right? I have one material copper, another material of same shape, okay, I will have in let's have mild steel. I will use mild steel. So technically, if I have two different material of same area, if area of a copper and area of a mild steel is same, okay, area is same, let's assume the volume is also same, but the material is different. And over this particular the this material, I'm applying some amount of force. However, the forces are applied, the forces applied are also same for both. Now the question is how it is going to affect their stress, how it is going to affect their stress, and how it's going to affect their strain. If I say the Young's modulus for this copper is 80 gigapascal and mild steel is about, 210 gigapascal, how it is going to affect their stress strain? So this is a very simplified version. We know what is stress is force with respect to unit area, right? Now, as in this both objects, we have the stress or the force applied on both this element are same, right? And area is also same. So I can easily say the stress occur for the copper is also going to be the same as the stress applied in the mild steel, right? I can easily say that. But whether the stress, as the stress is same, whether the strain is also going to be the same? No, because as per the strain has a huge dependency with the material. And what is a key property? Key property is the Young's modulus, which you can see over here, which is one of the key property over here. So obviously this is one of the important point to take away. So what is the important point you have? So kindly note it down simultaneously. It's going to help you for your understanding, or when you're revising, it's going to be helpful. So plastic, or sorry, so Young's modulus, which play a vital role while changing the strain for different material. So strain, when we talk about the strain, it is one of the dependent factor is the which material it is. And when I talk about the stress, it is independent of the material property, right? So this is one of the key point to take away. Next is Hooke's law, which is a very common thing. I don't think there will be any questions from Hooke's law, but they may ask some graphical representations, like they might give you like kind of graph, okay, and various kind of curvatures, and they ask you to pinpoint what are those nomenclature for this particular area. This is one possibility. Then this is obviously we have here strain, here we have our stress, right? Now there is another possibility. They will give you various types of graphical representation with the stress and strain. They might ask you to pinpoint what is this a material, the property of this material represent, what is this property of this material represent. So the if you see this B, here we can see at some point it's going straight. Then there is a small curve and deflection. This is the ultimate stress you can understand, and then leads to break at this point. So this is one of the nature which provides for the ductile material, for the ductile material. And if this same sort of thing, like a very negotiable changes over in the yield stress, so this is for the soft ductile material. For an example, you have copper, okay, soft ductile material, for an example copper. And the other one you can see it's going straight, and there itself it leads to break, right? Here itself leads to break. So this is obviously it's going to be a brittle material. So here you must be aware of what is a stress strain curve for different types of materials. So this is again comes for with the application based. Now talking about, there may be small numericals based on this. Okay, maybe some elongation they want. Talking about one more thing, Poisson ratio. I have seen many mechanical paper, or if you apply for ISRO or HL for internships in other competitive exam, they also ask the relation between the elastic modules. How you can relate with the elastic modules or modulus. So basically, we have this is another very very important. Last time also they asked one question from this particular topic, elastic modulus, and every time there are some relevant questions you can get from this elastic modulus. So please don't skip this. The time of exam, we feel, oh, we know this thing, we should have revised it. So this is one of the very easy topic, and don't skip this topic. So there are three types of elastic module. One is a Young's modulus, rigidity modulus, and is the your bulk modulus. Okay, three modulus we have. One is the Young's modulus, then we have the rigidity modulus, and another is the bulk modulus. So there are some authors, they represent different kind of notations. So Young's modulus E, rigidity G, and bulk as K. So they have a very unique relation among this. So please do remember that relation. So I will gradually write down that. So maybe it will be easy. So E equals to 2G 1 plus mu. And what is this mu? Mu is the Poisson's ratio. Mu is the Poisson ratio. There's another equation, E equals to 3K 1 minus of 2 mu. And combination of all three is E equals to 9 kg by 3K plus G. This looks very fancy thing. So you can try to remember this as well. So definitely, this is one of the very important, we can say, very important formula. You must not skip this, right? And side by side, they may not give you some Poisson value directly. So you should know what is the definition of Poisson value, transverse strain, to the longitudinal strain, which mathematically can be represented like change in diameter with the diameter by original diameter, change in length by the original length. So these are one of the very much important. It's very, very, very important. So definitely you will get this type of questions, and please do not skip. If not this, I will come to another connected with another topic where you need to use this. So coming to that, how there are different type of strain. Talking about this things, there is a volumetric strain, right, which is going to help you. There are many questions where you need to use the application of a volumetric strain. Now, as talking about, let's give a brief layout about Hooke's law. Hooke's law. What is Hooke's law? If I ask you to write, it's going to be delay. So let me write that. The stress is directly proportional with the strain within. This is one of the very important thing within the elastic within the elastic limit. Okay. So there is another way to write sigma equals to capital E into epsilon, which defines the strain, right? Or else we can write P by A equals to E change in length by L, right? Now same thing if I have to find, like with the change in length, okay, change in length, how I can write this? PL by EA. Now, if there is a problem, there may be this kind of problems are quite possible. You have three different sections, like here one section, compile with here continuation of another section, and then again another section. Yeah. All this A1, A2, and A3, and having different length. All are having different length. Now, how can you find out the elongation? Let's consider there is one force, some P is acting, a tensile force is acting. How you are going to find the elongation of this particular structure? This is again one of the very common question. So please do not skip this type of problem. Please do practice it, right? So this is a very rapid type of question. Only if the P is constant, put the P here. Simplified version, put the L1 by A1, E1. If the material is same, then the problem is solved. If they're different, use the different nomenclatures. Just follow this simple formula. L3, A3, E3. It's all based on the procedures, as I've said, mentioned here. The procedure. So these are simplified procedure, how it follows from a single step to the next level. Follow that. Okay. So as some of you have asked that we are coming to this point, but with top of that, let me clarify each and everything over here, how this play and what are the fine things that people do miss out. And each of this belongs a very scoring part on your gate exam when it comes to the gate exam point of view, right? So I hope I have made you clear till this area. What are the areas we have to? So here we have still not came with the Hooke's law. We are coming to that as well. Now, so this is a rough idea I have given you about this stress strain. You have to plan some different materials, okay, and there may be a possibility like kind of. I will give you another example. There is a graph, okay. Here we have a stress. Here we have a strain. We have different kind of shapes like this, then this one, then maybe like this, and they will might ask you to characterize the property, like which is going to be the most ductile, which is going to be the soft ductile, which is maybe the brittle, which going to be the most stiffest material. So that also you have to be clear with that. Now additionally, this is one of side of mechanical based question, they mostly don't ask to the aerospace, but still I would like to highlight that how we can, if they have given you some graphical representation, and if they ask you to find out the Young's modulus, and they ask you Young's modulus, how you can find from the graph. So remember, within the elastic limit, right, if you find the slope of the curve, that means change in your stress with the change in strain, right? This is your strain. If you solve this, you will get your what is your Young's modulus. There may be a small type of questions can come and may not come as well, right? So this is one of the another important point. Okay. Now, relevant to this, there is another important point that which comes to my mind: proof resilience, which is a connecting topic with this particular thing. Okay, so proof resilience is another maximum strain energy stored in a body within the elastic limit. So how you can find? If you find the volume of this particular region, okay, multiply with the product modulus of resilience. Okay, so if you want, I'm writing this thing. Resilience is the product of modulus of resilience into volume of body. So if you calculate that, so you will get this thing. Okay. So these are more deep into the thing. So you just plan and study according to thing. Now moving to the next another important topic. Definitely again you will get maximum 4 marks from this particular topic, and every year they're asking definitely 4 marks will be coming from this particular topic, that is transformation and Mohr circle principal stress. This is again a very 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 important topic. So here what you have to do is you have to remember the formula, as simple as that. You just remember the formula. Now here I will explain a bit about this thing. When we talk about this stress transformation, right? So basically this stress transformation are being classified in 4 cases. Actually there are from this we can classify them in the 4 case study: case 1, case 2, case 3, and case 4. Okay, if you can memorize the formula, well and good. If not, understand only the case 2, and rest the thing will be falling into the places. Okay, if you can memorize the formula, go with memorizing it. Otherwise, remember the case 2 alone carefully, and how this from case 2 are connected with case 1, case 3, and case 4. Do it. Now, what are this case 1, case 2, case 3, and case 4? Case 1 is direct stress condition. Okay. Case 2 is biaxial stress condition. Stress 3, it is I have only classified to simplified version, because when they will ask the question they will specify you whether it's a direct stress condition, they will specify you whether it's a biaxial stress condition, whether it's a pure stress or pure shear. Okay, sorry, pure shear stress condition, and another is the biaxial and shear stress condition, right? So this is one of the very important among all, and this is the second most important. So most of the time either they ask the biaxial stress condition or the pure stress condition, right? So what is the main thing you have to keep in mind, that if there is any plane, and in that particular plane there is if the load is acting like tensile forces, there is a cube, let's assume there is one box, right? And there is acting a tensile load, right? Now at some point, right, you are going to cut down into the principal plane. And what is a principal plane? The plane at which have no shear stress. Okay, so at some plane there will be a zero shear stress. That means mathematically the tau is going to be zero. Now on that plane, how these normal stresses are acting on it. Okay, so there will be different ways that stresses will be acting from that planes, sigma n, then here we'll be having sigma y. So then at what angle it's going to be zero, and what should be the angle, it's our main requirement to, or main objective to find out. So what should be the tau max, what should be the angle, and what should be our principal or normal stress, right? So each of it having a huge derivation. So here you're not going for the derivation, it's only with the formula. So how you're going to connect this formula into your this four different conditions, so you have to keep those things in mind. And there is a general formula where you have might have done or remembered, half sigma x plus sigma y plus half sigma x minus sigma y cos 2 theta plus tau sine 2 theta. This is a general equation. This is actually the general equation. To find the tau max, this formula is half sigma x minus sigma y sine 2 theta minus tau xy. So this is going to be xy is going to cos 2 theta. All right. So this is going to be your, okay, am I audible? Is my screen visible to all? I think it's fluctuating. Is it fluctuating? Is it fluctuating? Am I audible? Is my screen visible? Just let me know. Okay, hope my screen is visible to all. Okay, is it visible right now? Is it visible right now? All right, all right. So please communicate so I will be knowing that it's visible or not, so we can make the necessary things. Okay, fluctuating. Is it better right now? All right. May I continue right now? Okay. So this is a basic formula where you have to. Okay, now it's visible. That's great. All right. So we can continue it. Okay. So this is one of the, as we are discussing, is one of the very important formula to remember. Definitely one problem will come from this by using this formula. So I will suggest remember this formula. And there may be another possible ways to determine the plane having maximum or minimum of the direct stresses. So if they ask to find you the theta value, so this is the formula to find the theta value. So don't go with the nomenclatures. These nomenclatures might vary with the textbook to textbooks, right? So basically understanding the facts that what are the things are happening across this. So we need to split up all those forces together and like how you have to find it out. Now, similar to that, you have to find, using this principle, you have to find the maximum principal stress and minimum principal stress. Maximum and minimum principal stress. Now, there are two ways to ask, two ways that they are possibly ask this question. One is that some maybe some schematic diagram using Mohr circle, right? Or they might give you certain parameters and they will find out the answer. So what is the formula for maximum principal stress and minimum principal stress? So maximum sigma 1, minimum sigma 2. So this is the formula for that of sigma x plus sigma y plus and minus half root over of sigma x minus sigma y whole square plus 4 tau xy square. Okay, this is a basic formula. Now, sometimes they ask find out the radius of radius of a Mohr circle. So that means they have given you this parameters. They have given this parameter, but how can you find out the radius? If you combine this area, if you find out substitute the value for only this part alone. Okay, this part represents the radius of this Mohr circle. And if you calculate this region alone, it defines the center, right? So there is one tricks to remember, which I personally prefer. C plus and minus R. Okay. So just remember about the class representative, center and the radius. So principal stress defines the center and the radius of a Mohr circle. So just remember the class representative, CR. Okay. You know the plus means the maximum and minimum means the negative one. We're going to use it. Okay. And there are another ways to find the diameter. So as you know, if you're finding the center as sigma x plus sigma y, there is another way to find out the diameter of the Mohr circle, right? So if you just subtract sigma 1 minus sigma 2, that means this one minus of this, you will get the diameter. So obviously, the radius of Mohr circle can be also defined as sigma 1 minus sigma 2 by 2, which is equals to tau max. So there are certain formulas. This formula I'm quite sure is going to help you out in solving the problem. And as I've said, in this particular topic, they will give you numericals. They will give you a numericals. So this formulas are really, really going to help you out to solve your problem, right? So I hope simultaneously you're noting down or taking the screenshots of these things. Now we will move another core important. These definitely will be there. Each and every topic are very much important. In additions, there may be based using this particular theorem. They might ask you some kind of highlighting like at what case the shear stress is going to be maximum for the Mohr circle. What will be the angle? So obviously, if the theta is 90 degree, it's going to be the tau max. So such kind of small things which you can numerically find out even, okay, from here using this particular thing. Now moving to this important, another important phase is a Hooke's law and the plane stress and plane strain. Now these are again a connecting topic, the three-dimensional Hooke's law and plane stress and plane strain, right? So talking about this three dimension of Hooke's law, right? As you know, the Hooke's law, that is sigma, that is stress, is directly proportional with the strain. So this we are been framing into the coordinates. So coordinates in the sense we are transforming into the matrix form. We can solve this thing in a matrix format. So how we can form into a matrix format? So we consider any body which is an isotropic body. Okay, considering an isotropic body. So we can write this as sigma xx, sigma yy, and sigma z, tau xy, tau yz, and tau zx. So this is framing one coordinates, which is going to be equals to Young's modulus of 1 plus mu into 1 minus of 2 mu. Obviously, there is a huge derivation, so nobody is going to uh, remember the derivation over here. The only thing which is going to be useful here is that your formula. So this is going to be around 6 cross 6 matrix you will be forming. So here also mu, here also mu, 0, 0, 0. Here you will have 1 minus mu, mu, 0, 0, 0. Here you will have mu, 1 minus of mu, 0, 0. And rest here 0, 0, 0, 0, 0, 0. Here we have 1 minus of 2 mu by 2. Okay, 0, 0, 0. Again, we have 1 minus of 2 mu by 2. So this is one kind of derivational things. But again, I'm telling, here you don't need the derivational thing, but you need to remember this equation. So if you follow some 2 years back question paper, last 2 years, they have rapidly asked lot much of numericals from this particular equation, right? So they will give you some terms and conditions. So some of the parameters you need to consider them as zero, right? And what is the terms and conditions? The terms and conditions is that whether the plane is whether the plane stress condition or the plane strain condition. So based on these two conditions, you have to substitute the sum of the parameters to be zero. So here again, it is one of the important, very, very important topic. So here you can also get like a reason type question, reason type questions, some multiple selection based questions. You can also get numericals. There's a high chance of numericals, and obviously it's a very important. Definitely one question will be there. So do not skip. Prepare. It's a very fine topic, very fine concept. Prepare it thoroughly. That will be my suggestions. And talking about like, let's discuss what is plane stress and plane strain. Like if you want me that, so let me give you some overview about this plane stress. What is plane stress? It is defined to be a set of stress in which this normal stress and normal strain are directly perpendicular with one another, and as it is perpendicular to one another towards zeroth plane. So the other plane, that is a z plane, the stress on the z plane is going to be 0. And so accordingly, so whatever the shear stress around the z plane is also going to be the 0. But the shear strain, right? The that is epsilon z is not 0. This is the idea behind this plane stress. This is the idea behind the plane stress. Same thing with the strain. The sigma z is going to be 0, but all other factors is going to be 0, but not the stress is not going to be 0. But if I talk about sigma xz and tau xz and tau yz will be 0. Even the shear strain for xz and shear strain for yz is also going to be 0. But in the plane strain, the strengths along the z direction is going to be 0, but not the stress, right? So based on the conditions, there may be a question, right? And if I count these things, like initially without isentropic body, it's an orthotropic body, it's going to have 36 elastic constants. 36, because if you cross 6 cross 6 is 36. So as it's an isotropic body, so it becomes a only two constants. It has come down to two elastic constants. So this is also several times they ask the in gate examinations. So if it is isotropic body, what will be the number of elastic constants? So it is going to be two in number, right? So then next it comes whether it's a uniaxial stress or it's a biaxial stress, how they are going to act. Now this particular topic is quite related with the another topic, and you can there are some numericals on that using compatibility. We call as a equation of or equation of compatibility. So definitely, this is again another important question. Okay, again another important question. So I will write down the equation over here, which is called as a equilibrium compatibility. Equilibrium compatibility. So there's a formula, dou square epsilon xx by dou y square plus dou square epsilon yy by dou x square equals to twice of dou square xx by dou x dou y, right? So definitely there will be one question from, sorry, it's going to be y. So remember the equilibrium of compatibility, right? Or we can say sometimes conditions of compatibility. This is again, I'm telling you, one of the important questions. And similarly to this, then Airy stress functions and how this plane stress and plane strain are connected, right? Now, coming to failure theory. Yes, failure theory are just again quite connected with this principal stress. So they are basically important five failure theories. So among the five failure theories, remember their application. How their what is the application and the formula? What is the name of the scientist? Uh, what are the constraints? Remember that. That will only serve the purpose for this particular topic, right? So these are very rare question for failure theory. Hardly they ask, hardly. Maybe 1 marks we will get it, right? Then talking about strain energy, yes, the strain energy and solve to solve the problem, using strain energy and to solve the problem. Now what happens? You have to remember the Castigliano principle and Castigliano method. Okay, so for knowing this Castigliano principle and Castigliano method, so you will get frames or truss problem, right? So how the strain energy and what is the formula for the Castigliano theorem, how to, you have to remember the procedure for this, how to solve a single problem, what are the shortcuts, whether they have given the beam, whether they have given the frame, right? So whether they have given the truss, so accordingly how you're going to use the Castigliano principle, right? So that procedure, it's a very vast topic, you have to remember this thing. And there is a chances of having one problem from Castigliano theorem or the bending, right? Castigliano or the statically determinate or indeterminate problem, like beams, structures, trusses. Definitely, one problem will come from the truss connected with the column. Like they will give you one truss problem. Definitely, the truss problem is quite common in all the gate aerospace question paper. Truss is one of the they are asking every time. Truss problem. Okay. So what the kind of questions they might ask in the trust? They will give you some kind of structure. Okay. Maybe different type of loads. Yeah, we have a. You have to understand what type of loads they have provided. So where the loads are acting, right? Whether they are acting like this or this. What is the dimensions they have provided? Now suppose they have given one structure like this. Okay, and they have given 2 kilonewton, then here have 3 kilonewton, here they have given 5 kilonewton at this point. They have given some angle, this 30 degree, this is 60 degree. Okay, some things, some other parameters, maybe it's 4 centimeter, this is 8 centimeter, some random things I'm writing over here. And they ask you, they might ask you which point will have leads to buckle first. Okay, so first you have to use the critical um, uh, Euler's equation, critical load formula. Okay, using Euler's principle, which is like pi square EI by L square, right? So at what, there are four important conditions are there, like both the ends fixed, one end fixed, one end free, both the ends hinge, one end fixed, one end free. So based on the four end conditions, based on the four end conditions, this formula is going to modify. And first you have to find out the critical load or acting on this particular structure. So where you will have the list value, so that is going to be the buckle first. So you have to identify maybe the structure, maybe what is amount of load or some other things. So this is a combination of truss and the we have the truss and column problem, right? So which is also comes under the statically determinate structures, indeterminate structures. When we talk about the statically determinate, indeterminate, we have this fixed beam, popped cantilever beam. What will be their shear force diagram, which is the correct one for that particular figure? Shear force diagram, then bending moment diagram, what will be their slopes, what will be their deflections, all those things. So for this, again, you have to remember bending equation and its other things. Okay, so bending equation is again another important, which is m by I equals to sigma by y e by r. Okay, so how these parameters are interconnected? Okay, how these parameters are interconnected? Maybe some questions from neutral axis, some question from centroid, how their CG, how will you calculate the centroid? Maybe they have given you some small sections, they will ask you to find out the centroid for that particular section. There may be a question. Okay, and talking about centroid, yes, upcoming, there is another topic in the next one: torsion, bending, shear flow in the thin wall structures. This is again a very, very, very important topic. Okay, the torsion, bending, and shear flow. So you have to find out what is the your your torsion equations. So how the torsion equation are connected with one another. Torsion equation, right? And if it is a multi-cell structure, right? If it is a multi-cell structure and there is a torque occurring, so the twist angle for the cell 1 and cell 2 is going to be the same. And if the length of the beam is same, right? So we can consider beta equals to angle of twist per unit length. So beta of the cell 1 is going to be the same as beta of cell 2. So there are some numericals where you have to use using Brett-Bato theorem. Okay, this is please don't skip this particular problem. If you want, at the end of the video I will drop those things in the description box as well, how you can there are some numericals which I've already solved using Brett-Bato theorem. So please do practice. Definitely one problem. So last year the problems which they have asked, it was quite lengthy. Okay, so we cannot uh, directly say the paper is going to be lengthy or not lengthy, right? So please be planned your things accordingly. So this is one of the very important topic. Definitely the questions from this particular topic, again 2 to 4 marks will be coming, definitely, from this topic, or at least from the bread relevant to Brett-Bato theorem. The concept here is the twist angle is going to be the same because it's a rigid, right? It's going to be the same. And this is, they have used a principle using torsion equation to solve that problem, right? So this is again another important topic uh, over here. Then rarely based on simplified 1 or 2 marks. These are rarest of rarest thing. Characteristics of aircraft structures, maybe from monocoque, semi-monocoque structures, loads acting on the aircrafts like air load, gust load, what, how they're connected with one another. These are rarest of rarest question, theoretical based. Now, another this part vibe. This part of already we have discussed. Aerostress function. This thing we have discussed. Yes, coming to this point, vibration. This is again an important. Coming to the end of our your structures too. That talking about the major questions arrive from here. Okay. Now. Okay, let me share one more equations with you guys. All right, so just talking about the elasticity. I hope that was going to be helpful for your future use. Um, this two-dimensional compatibility relation. It's two-dimensional compatibility relation. So one is for your plane stress and one for the plane strain. Okay, so plane stress, it is dose power 4 pi by dou x power 4 plus 2 dou power 4 by 5 by dou x square dou y square plus dou power 4 phi by dou 4 equals to 0. And for the plane strain, it is dou 4 pi by, it's a function. Okay, the one kind of functions will be elastic functions will be given to you, so you can make use of that, of this phi. And if you partially differentiating, and you will get some result out of it. Okay, so 1 minus of mu equals to 0, right? So this is one of the another important. Okay, now coming back to the vibration, right? This is definitely another very scoring part. Again, you will get 4 to 6 marks, especially on this topic. So you can understand out of all those things, right? Especially from this topic, you will get 4 to 6 marks, including 1 mark, including some MC multiple selection based questions, including some numericals. Definitely 2 3 numericals will be there. Okay. Now let's first understand the strategy. What type of? So one is a theoretical, like based on the concepts, what is mean by displacement, velocity, acceleration, how you denote them, or how you denote the damping forces, how the damping forces relate with the spring forces, how the spring forces relate with the inertia forces, right? What are the different parts? So basically, mathematically, we can denote this as like this. So this M defines, or mx double dot defines your inertia force, right? And kx defines your um, spring force, and this one defines your damping force. Okay. Now, this is one that they will give you some of the parameters and you have to find it out, right? What you have to find? There are two ways, two things you can find. One is a damped frequency, one is a undamped frequency. Now, you have to check the unit what they ask, whether they have asked in hertz or the radian per second, right? So accordingly, your formula is going to vary. If they ask that fine, tell me the answer in terms of radian per second, that means you have to use this formula, right? Natural frequency, it is omega equals to root over of k by m, that is spring constant by the mass. You will get the answer in radian per second. If they ask in terms of hertz, you have to use Fn equals to 2 pi root over of k by m, which is nothing but which is nothing but we can write omega n by 2 pi. And opposite of frequency is a time. So if they ask a time cycle, so 2 pi by omega n. Some simplified way you have to find. Now, sometimes this they might give you one beam and they will say all the parameters of the beam, and they will ask what will happen with the vibration of it based on the which type of load. So this formula has a unique connection with the deflection, because if there is any beam, if the load occurs, it will deflect, right? So how much amount of deflection though has a direct connection with the spring constant. So if you are not knowing this relation, so please note it down. This the spring constant into deflection equals to m into g. Okay, so this can be also be written as k by m equals to, if I bring this, you will get g by del. So there is another way we can write this formula, g by del, right? So there are a lot many problems or numericals you can see. They've given one beam and they ask a vibration, right? And if they say there is a pointed load acting at the end of the cantilever beam, so you must be aware of the deflection formula. So if the same kind of thing, we know that at the cantilever beam, point load at the end is W L cube by 3 EI. So we can use that over here. That is mass is W, which is M into G, right? M into G. We can implement that over here and we will get the result. So there are a lot many tricks, and as I've said, we have said now we will talk about the connectivity, right? Interconnected, how the parameters are interconnected. I can say this is one of the best example. How from the deflection problem we are comparing with the vibrations. So this is one of the very good example I can say, and this is what the gate, the whoever sets a paper, they make use of this thing always. In the last moment I will not suggest you to go for the interconnections or study something new. This is a time to refer whatever you have studied, just brush it up, just practice as much as you can. Okay, try to clear, read as much as you can with the same topic. Don't go with some new topic. This is not the time, because you have not even 1 week, right? So this is a time that you have to brush up the concepts. Okay, so do as much as you can and practice it. Okay, because at the end you only have to practice it. So let's see if we are doing this and how we can find the frequency. So just put up those things over here. Sorry, this already G is over here. So what type of answer you will get? So the omega for this particular scenario is G 3EI by mg L cube, right? So let me cancel off this G and G, root over of that. So I will get root over of 3EI by m L cube. And if this Young's modulus, if the I value is given, if the m value is given, you can find out the answer in terms of radian per second. And if they ask in hertz, so you can also write like half 3EI ml cube, right? And if they say the cross section of the square and they have given the dimension, so you can find the I, okay, b d cube by 12, right? Again, you can find out what will be the answer for it. Now, so likewise, there will be a problem like you have free, you have that degree of freedom, damped free, okay, damped free, undamped of 2 degree of freedom. They will give you like a structure like this, one mass over here, then another mass is connected. However they want, they can have it, right? There's a different type of springs with different constants, right? There will be a roller. So what will be their nodes? What will be their different frequency? So this is again an important one. You should know how to find out the mass of a single body, right? How to find out the mass. You have to again come back to the same simplified version of this equation, right? Again, yeah, as there is no we don't have your damper, right? So that's why the cx double single dot is going to be 0, right? So if it is there, how you are going to frame the equation? So they, you just practice those things. At the end of this I will put all the links together. And in between this I have skipped, remember one more important topic when we are talking about this torsion and bending is the shear center, which is one of the important topic, is the shear center, then shear flow, shear center for different cross sections, different cross section. If it's a L, T, I, if it is a like rectangular or closed sections, etc., etc., etc. So this is again another connecting topic and very, very, very important topic when we are talking about this torsion and this. Okay, so I hope I have given you the overview. So if you have any particular things, particular questions, so I like to clarify based on the tips, any other additional tips if you are looking forward. Because it's just a 1 hour sessions. So I will love to clarify if you have certain things regarding gate or some basic things from my end. So there, so I will looking forward for your answer. Till then, I'll be sharing some important formulas which may be useful for your future use. So one of them is a damping ratio. So there may be a problems on damping ratio. So which is C by Cc, or also known as C by 2m omega n, or C by 2 root over of km. So K, all and M, I hope you were clear with that. And what, so from here we can understand what is critical damping, right? Critical damping is like 2 root over of Km. We can also write that. So apart from that, there are damping natural frequency, damping natural frequency, which is denoted by omega d, which is 1 minus of equals to root over of 1 minus of damping ratio square, okay, into omega n, into omega n. And here keep in mind that always the damping natural frequency is going to be less than the natural damping frequency. It's always going to be less, right? And as here I have discussed about the time, so this thing will vary. If it is for natural damped, it is a natural damped, so it will be going with t equals to 2 pi omega n. If they ask that damped time period, so here you have to write like the damped frequency, obviously. So as per the required questions. Now there are some questions they ask about this logarithmic um, uh, decrement. Okay, they denote as del equals to ln by x2, which is nothing but 1 by n. This is number of cycle of amplitude, which is also like it can be done in many ways. So you have to remember this x1 x2s are the amplitudes. Okay, these are the amplitudes. What is the number of cycle of amplitudes they have asked? So this is again very scoring. There may be a possibility they are asking questions on basis of this particular formulas. Okay, so I would like to know that how you felt about the session till now. Whatever things I have discussed, you want me to specify some particular things that any other topic like uh, on that particular topic that what are things you can study. If I miss something, I would like to know any other things that I've ever skipped. That you, as you are preparing for it. So for one more thing, talking about the tips and tricks that there are a lot many things like deflection problems. This is one of the how you can remember the deflection thing, right? Deflection problems. So let me share one part of it. Uh, Let me share over here. So this is one of the challenging, like for each and every loads and everything, how you can remember these things, right? How you can remember the formula. So for that, I would like to share. I would like to share the link. I would love to share the link in the chat box. Would love to share the link in the chat box, so you can for your future use you can refer that. Okay, and talking about your shear flow, so that also I will share the link. So meanwhile, if there are any questions are welcome. Any other questions, I love to entertain that. And if you have no, I would like to know that how you felt about this session. Is it useful? Did you learn anything new? Um, and and just I just want to know how you felt about the session. So I'm going to share some of the links over here. Okay. Otherwise, I will share the playlist, so there you can find a lot much of playlist over there itself, right? And now, if you have no questions, it's okay. So, in from my end, I would like to give you certain suggestions that the pattern that Gate follows. Okay, Gate the main their thing is they will try to make you confuse. Okay, so as a student, obviously, it's a very common thing to get it confused. Thank you, Vishnu, and I hope you have taken away many things from this particular session. All right. Um, okay. So, all right. So coming back, some of the tips. So avoid. So what of now? Let me tell you some of the things what the student do it. Okay. So if you know what to do's and don'ts, okay, don't rush up reading it. Okay, you will feel okay, I have solved this problem, and you will start it. But at the end, it will the output is going to be different. So never rush up and read it. Read, be very calm, be very relaxed. Moreover, relax and read the question carefully. That is going to be the first and foremost. Read the question carefully, right? Read the question carefully. This is where the student do mistake. If there is a units, try to convert all in the simple unit. What the question they ask, what should be the unit of that? Please be careful with that, because sometimes they have given I need an answer in kilometer per second, and you have given meter per second. So though the solution is right, the answer will be done as wrong. So be very careful with your units. And few more things, like try to relate with other things. Okay, how those parameters are connected when you are preparing it. Okay, understand what they're asking it. Understand what they're asking it, right? And if don't waste time, don't waste time on same question for a longer time. You might think that that particular topic you are prepared so well, but you are unable to get the question, or what will be. You keep on thinking it. So stop wasting your time on that. Okay, don't waste your time on thinking about that particular answer for the particular question. Rather, you just they will be providing you scribbling paper, scribbling note. So rather keep that thing aside and move. You can review that answer in the last. If you're not answering it, it will be considered as not answered. Fine. So remember each and every question whenever you're attempting. After clicking save it. Okay, do save the answer, then move to the next. Read and keep some time for reviewing your answer. Reviewing your answer. Review it. Have some time. Have some time management. Okay? Have some time management. And as you have still some 2 3 days left over for preparations, and still obviously will be preparing, have one small note. Small note. So what are the most confusing thing you feel, just write down on the note. So before going into the exam hall, you can recap those things. Okay, and at present, don't try to learn something new. Practice. Okay, practice as much as you can. practice a solve paper. So that will help you to build your confidence, that will help you to build your ideas, and that will have to build your concepts as well. Try to solve as much as you can. You can take a reference from engineering science paper which is close to this particular topics. You can take from mechanical, you can take from ISRO papers. There are some exams which is conducted through them, right? Go and refer those things, right? So I think we can wind up over here. Any more questions are welcome. I'm just right here. So, any more questions from your end? Your issues, you're facing some problems. So, I will try to resolve it from my end. If you're facing any issues from your side that you're facing some trouble, I will be glad to help you out. I will be glad to help you out. Any other issues? I'll be okay. So, I hope no questions. I will happy to help you out. All right. So, hope you have loved the sessions. Um, okay, thank you, everyone. Thank you so much. Um, all right, then. So, meet you soon with the propulsion. Uh, so, please, I will keep on updating our. Tomorrow, we will have for mathematics, and next day, we'll have for propulsion, right? So, please be updated with our channel. You will be notified, right? Okay, thank you everyone. Have a nice day and good night. Take care.